I don't know if you can see what time it is, but it's 11:20 at night. This is for you. For you. I do believe your end of course test matters, and I hope you make as good a grade as possible. The questions that I'll be going over the next couple of days, including tonight, all come from Pearson, the people who make your EOC. There's some incentive, which I'll talk about probably Wednesday. Hopefully I'll be here Wednesday. For you to do well, because for some of you, it's your only chance. So here's some lower level questions. What do these things mean? And it'll be in words. What does 6 to the 1/2 mean? The idea is that a kid understands x to the power over the root. So in words, 6 to the 1/2 means literally the square root of 6. Because this is 6 to the 1st under a square root symbol. You understood too. What does 42 to the 4/5 mean? Well, that is going to be the 5th root of 42 to the 4th power. That's in words. And that comes from this being the power sitting pretty over the root. It's probably my, where's my phone going off? Oh, it's Reddit. So that ought to be easy. Determine which expressions are equivalent to 27. Now, questions like this are not supposed to be on the calculator part of your EOC. These are not calculator questions, plain and simple. I can't even spell calculator, I'm so tired. These are not calculator questions. Plain and simple, they're not calculator questions. So equivalent 27. All right, so what they're relying on you is to remember your little rule about x to the a times x to the b is where we add exponents. So 3 squared times 3 to the 1/2 times 3 to the 3rd would be 3 to the 2 plus 1/2 plus 1/3. And believe it or not, that's a 5th grade standard. That is not necessarily the rewriting of exponents, but 2 plus 1/2 plus 1/3. You know, 2 plus 1/2 plus 1/3, to add fractions that have the common denominator. So 2 is going to be 6 over 3. Oh, sorry, I ain't even doing that. I need to be thinking about over 6. 2 is going to be 12 over 6. 1/2 is going to be 3 over 6. And 1/3 is going to be 2 over 6. And if I take that string of numerators, 12, 3, and 2, and put them together, I get 16 over 6, which doesn't reduce very well. That's what, 8/3 power? All right, that's not going to be it. The reason I know that's not going to be the answer is because 27 is 3 cubed. It is. I swear, you do 3 times 3 times 3, you get 27. And the exponents did not add up to 3, they added up to something else. So that one's gone. The second one, the understood exponent here is a 1. So I'm going to change that to a 6 over 6 plus a 5 over a 6 plus a 7 over a 6. And when I'm done with this long string here, I'm going to have 3 to the 18 over 6, which is 3 cubed. Aha! And it says which. There might be another one. There might be. 81 to the 4/3. Again, this is the power. This is the root. Yeah. Ugh, that's going to be ugly. I don't even think it's doable. This would be the 3rd root of 81 all to the 4th. It's not going to be 3 cubed. That might even be the best way of doing this. This might be a better way. 81 is 3 to the 4th power. This is 3 to the 4th times 4/3, which becomes 3 to the 16/3 when you multiply. 4 times 4 is 16. That's not 3. It's not. So, gone. 3 to the negative 2 times 2 to the 15 thirds. I'm betting that's supposed to be a 3. This is probably a typo. I guarantee you that's a typo. It's too late to fix it. I already made copies. Well, 15 over 3 is 5. There we go. There were 2 of them. It was a multiple select problem. All right. The board will agree with me, and I wish it would, because it's almost 11:30. Evaluate 7 to the 3/4 over 7. By the way, that 7 is 7 to the first, and if you write this as a proper fraction, I just didn't have time to type everything up nicely. I'm thinking about the rule x to the a over x to the b. Now, there's a couple ways of doing this. You can do x to the a minus b, or you can do 1 over x to the b minus a. 1 is bigger than 3/4. It really is. So we're going to do 1 over 7 to the 1 minus 3/4, which is 1 over 7 to the 1/4 power. Done with that one. Rewrite the cubic root of 24 plus the square root of 27 plus the cubic root of 81. This is going to be something that bugs some of y'all. There's nothing I can do about it, and these are not calculator problems. To get to a 24, my brain is thinking 8 and 3. It is late. To get to a 27, and by the way, this is the square root, the 2th root, so I can only think about things I can take the square root of, which would be 9 times 3. And then the cubic root of 81, cubic root of 81 is going to be 3 to the 4th power, or 27 times 3 is probably the best one. Just depends on how you think. And now what I've done is I've rewritten things so I can evaluate the roots, and hopefully I can come up with something here. I won't be able to do much with this. The cubic root of 8 is 2, so this becomes 2 cubic roots of 3. The square root of 27 is going to be 3 root 3, and notice that the symbols differ. You can't actually add those together. And the cubic root of 27 is 3, so 3 cubic roots of 3. Now there's a pair of like terms here. That guy and that guy are alike. They can be added. You know, my 5-year-old can do this. 2 plus 3, by God, it's 5, right? So there's 5 cubic roots of 3 plus 3 square roots of 3. And that is as far as you can go with that by hand. These are not calculator problems. Simplify the 5th root. Look at this big old thing. 5th root of 81 x to the 7th y to the 12th over 729 x to the negative 3rd y to the 7th. A lot of stuff going in there. 81 and 729, that's what I'd focus on first. There is no 5th root of 81. 81 is 3 to the 4th. 81 will enter 729 9 times, I think. That will reduce down to 9. Is there anything else I can do with this? Here's what I'm going to do. I'm going to rewrite them as powers of 3. 81 is 3 to the 4th power. 729 should be 3 to the 6th. I might do something like that for a second. But yeah, all right, that was right. That's 1 over 3 squared, 1 over 9. I don't know if I'm going to do anything with that or not, but it does reduce. So 1, 9. This is where you can do your work. X to the 7th over x to the negative 3 is x to the 10th. Y to the 12th over y to the 7th is y to the 5th. This is a 5th root we were taking. Now, I told you this a long time ago. All you had to do was divide the power by the root. So 5 goes into 10 twice. There's an x squared out front. 5 goes into 5 once. There's a y out front. And what you're left with is nothing you can do anything with. It looks like that. Now, that being said, this is an EOC test. What somebody might have done, and this is something that's doable, is they might have reduced this down to 3 cubed over 3 to the 5th. So that's worth exploring. It is. Sorry, that was 3 cubed. So let me replace that back in place. Instead of that 1/9 there, I go this route. Well, the 5th root of 3 cubed, there's nothing you can do with it. You just leave it as 27. That's all you can do. You can still do 10 divided by 5 is 2. 5 divided by 5 is 1. Now, you can take the 5th root of 3 to the 5th. It's 3. So this is also a very acceptable answer. That's a 27 out of 20 y. Or that one. And I'm not sure which one they're going to do. I'm not. But they can go either way on that. Could be multiple select. Think about that. Come on, board. Sorry, I'm wasting your time here. It's wasting mine too. Find the product, the square root of 4x to the 4th times the square root of 49x squared. Ideally, what you would do here is you would just figure this out. I mean, the square root of 4 is 2. The square root of x to the 4th is x squared. There's supposed to be some absolute value symbols on there, but the state of Tennessee doesn't follow those rules. The square root of 49 is 7. The square root of x squared is x. And 2 times 7 is 14. X times x squared is x cubed. That's not so bad, is it? That's easy. 6 of 11. Which expressions can be rewritten as k, or k as an integer, root 5? Several of them. 125 is simply 5 times 25. So this would be 5 root 5, because the square root of 25 is 5, for those of you who don't know it. So here, that works. That one, for sure. Root 50 is root 25 times 2, which is 5 root 2. I wanted root 5. Big fat no. Very good distractor. 45, root 45 would be root 9 times 5. This is a winner chicken dinner. Square root of 9 is 3. So there we go. Got the root 5. That one. And root 25, oddly enough, yes. Root 25 can be thought of as root of 25 times 1, which becomes 5 root. Oh, no, it's not. That's a gone. Sorry. Having a brain part there. So it was A and C. What are the x-intercepts of the following? The x-intercepts happen when y is 0. So this is a big fat 0 right there. And now because of that, we can use the zero product property. So 2 is just a number. We only think about things with factors of x. So x minus 2 could be a 0. X plus 3 could be a 0. X minus 4 could be a 0. So I get that x is 2, x is negative 3, or lastly, x is 4. It's just as simple as changing signs in lead parentheses. In the function, the amount after time passes is 250 times 1 minus 0.05 t. What does the expression 1 minus 0.05 represent? That is telling you what's going to be left. 1 minus 0.05 is 0.95. So what is this telling you? This is telling you that for every interval of hours or minutes or seconds, only 95%. So as time increments 1 unit, I don't know what it is, it could be minutes, seconds, who knows. The function decreases by 5%. It's a decay function because 5%. It's just telling you how much it's decaying. So that's a pretty simple little question. I may not have that worded right according to Pearson, but it should be good enough. And I'm too tired to think about the questions I pulled for that right now. The area of a rectangle, whatever that is given as a equals 24x squared minus 18x minus 15. Find the dimensions of the rectangle in terms of x. This is meant to be something that you factor. That's what it's meant to be. You know, I know that the area of a rectangle, the g in it, is length times width. It's something times something. So I'm going to try and factor it. To make a 24x squared, I'm going to take a 6x and I'm going to take a 4x. A 15, I'm thinking 5 and 3. 4 being 6 times 4, 5 times 3. I have to add to negative 18 when I FOIL. And again, 15, I'm thinking 5 and 3. And I feel pretty good about that. The outside would make 30x, and the inside would make 12x. And if I do a positive 12 minus 30, I'm in business. Because that'll work. So one of these could be length. And it's a horrible and. 4x minus 5 is width. It doesn't really matter which one's which in terms of algebra, but there you go. What's up with this one? What does each number represent in the equation? This thing is in the form y equals a times x minus h squared plus k. So what does each number mean? We'll start with the 4. The 4 is, I always taught you guys this is initial slope. You will not see that on the EOC. Forgive me, I'm too tired. Again, that was initial slope. But the 4 represents the vertical stretch. This thing is 4 times as tall. The 3 represents the horizontal shift. And we always do opposite with it with x. So this is going to be a right 3. And the 2 is the vertical shift. And it's the one that you trust. It's literally up 2. H is literally for horizontal. I mean, I have no idea why they call it K, but H is for horizontal. So that's not hard. About half of you understand that. Which is pretty good in Algebra 2 class. I have this crazy dream that you guys are going to be in the 99th percentile for growth. I've hit 3% percentile for growth in classes. For Dresden High School, that's amazing. Title I school, all that. A rectangular chord has an area of 10x squared minus 11x minus 6. Select all the following to represent side lengths. Again, it's a rectangle. So area is length times width. This is like what we just did. This is factoring 101. I'm thinking 10 is probably 5 times 2, and I'm thinking 6 is probably 2 times 3. So let's try a 5x and a 2x. And if 6 is 2 times 3, I want to add to negative 11. When I FOIL, which is something a lot of you can't do, something you need to work on. How do we want to do that? probably with a 3 here and a 2 there, because the outside makes 15x and the inside makes 4. And a negative 15 plus 4 is a negative 11. So minus 3 plus 2. So I'm looking for 5x plus 2, she's right there. I'm looking for 2x minus 3, she's right there. Again, all of this is non-calculator. It is. All right, so back to this one. I changed this one. So if you're following along, I changed this problem. I did it earlier and I realized I had a problem. Now, volume of a box is length times width times height. That's how you find the volume of a box. One of these factors is either the length, the width, or the height. And we're going to do this by using synthetic division. Okay, this might be the length, might be the width, might be the height, and so forth, but we don't know. What we're going to do is we're going to do synthetic division, and we're going to hope that we get a 0 as a remainder, because if we get a 0 as a remainder through synthetic division, we have a factor. That's how this works. Now, first off, you have to understand, if you're dealing with x plus 6, if x plus 6 is a factor, then x plus 6 is 0, which means that x is negative 6. So, when I do synthetic division, I'm just going to change these signs. This is literally x equals 0. This would be x equals 5. This would be x equals negative 2. This would be x equals 4. And I'm not going to do all of these. I know what the answer is. I just had to recreate this problem. But let's pick a wrong one. Let's try that negative 6. We're going to do synthetic division. We're going to load the second floor with coefficients 1, 2, negative 12, negative 24. We're going to follow that acronym DMA. We're going to drop. Negative 6 times 1 is negative 6. 2 plus a negative 6 is negative 4. Negative 6 times negative 4 is 24. Negative 12 plus 24 is 12. Negative 6 times 12 is negative 72. And the sum is negative 84. I just learned x plus 6 is not a factor, because I want a 0. I don't have it. Let's try the 0. Repeat it. 1, 2, negative 12, negative 24. Oh, I screwed that up. That would have made that different. Still isn't going to work. I drop. I add. I multiply. I add. I multiply. And I add. Ain't that one either. We'll move on to D. Mainly because I'm tired. It is 11:50 right now. And I'm ready to go home. I've still got to type up a letter for the substitute. Then I can, after I do a little editing on the video, get rid of some bad stuff, I can go home. I might get out of here by 12:15. See what happens if we synthetically divide out the negative 2. 1, 2, negative 12, negative 24. I drop, I get a 1. Negative 2 times 1 is negative 2. 2 and negative 2 sums to be 0. Negative 2 times 0 is 0. Negative 12 plus 0 is negative 12. A negative times a negative is positive. And there we go. That's my remainder. What I just learned is I learned that x plus 2 was in fact equal to 0. Goes back to all this stuff. It is in fact equal to 0. This is one of the side lengths of my box. It might be the length, might be the width, might be the height, but it's one of them. And that is review day 1. There's 5 days review. That should cover all the old algebra. Anyways, that's it for that. 11:51, still got some stuff to do. You're welcome for this, by the way.